Welcome to IBM Security QRadar SIM Foundations. My name is Luis Latas, Worldwide Technical Sales Enablement, and I'll be the instructor for this class. This course is divided in two parts. The first part of the course consists of describing the SIM capabilities, such as how QRadar SIM collects and processes data. I will also describe the different deployment and appliance types. In the second part of the course, I will describe the user console such as the dashboard, log activity, network activity tab, and other capabilities of QRadar. I will also describe how a search can be created and the best practices in building one. Finally, I will go over the concept of offenses and describe the different fields that constitute an offense. QRadar SIM identifies suspected attacks and policy breaches. By doing so, it helps answer key questions such as what is being attacked, what is the security impact, who's attacking, where should the investigation be focused, when are attacks taking place, how's the attack penetrating the system, and, very important, is the suspected attack or policy breach real or a false alarm. It provides context to the information collected. It enables security analysts to perform investigations from correlated information. That information consists of point in time, when did the attack or breach take place, offending users, origins, targets, also vulnerabilities, asset information, and known threats. To identify suspected attacks and policy breaches, QRadar SIM has to process security-relevant data from a wide variety of sources, such as firewalls, user directories, proxies, applications, and routers. It also collects, normalizes, and has the ability to correlate and securely store raw events, network flows, vulnerability assets, and threat intelligence data. It can also capture Layer 7 payload up to a configurable number of bytes from unencrypted traffic. It has comprehensive search capabilities. It can monitor host and network behavior changes that could indicate an attack or policy breach, such as off hours or excessive usage of an application or network activity patterns inconsistent with historical profiles. Also, it can monitor prioritization of suspected attacks and policy breaches. It provides notification by means of email, SNMP, and others. It can generate reports from many templates. It provides a scalable architecture to support large deployments, and it is managed and viewed from a single user interface. This single user interface provides access to all tasks and features in QRadar, such as viewing offenses, events flows, vulnerabilities, creating reports, rules, and also perform administration tasks. QRadar processes and normalizes security-relevant data so it can be correlated and used to provide security-relevant information. It processes events, which are records from a device or devices that describe an action on a network or hosts. QRadar SIM normalizes the varied information found in raw events. Normalizing means to map information to common field names. For example, src underscore IP, source IP, and others are normalized to source IP. User underscore name, username, login, and others could be normalized to user. Normalized events are mapped to high-level and low-level categories to facilitate further processing. After raw events are normalized, it's easy to search, report, and cross-correlate these normalized events. In this slide, I will describe how QRadar collects and processes events from the different log sources. Log sources such as firewalls, routers, and servers typically send syslog messages to QRadar. They can also use other protocols such as Logfile, JDBC, and others to send events to QRadar. These messages are first collected by the event collector component. The messages are in raw format. The event collector component uses the device support modules or DSMs to parse and normalize raw data. Raw log messages will always remain intact. Event collectors do not store raw or normalized data permanently. The event collector component is usually present in event collectors, event processors, or all-in-one appliances. Event processors receive the normalized events and raw events and then analyze and store them. Analyzing means testing rules against those events. The event processor component is present in event processors and also in all-in-one appliances. Data nodes, not pictured in the slide, provide additional storage for event and flow data. These data nodes will need to be associated with an event processor or an all-in-one appliance. The magistrate component correlates data from event processors and eventually QRadar offenses. The magistrate is present only in the console or all-in-one appliances. QRadar SIM has also the ability to collect and process flows from network devices. A flow is a communication session between two hosts. Think of it as a conversation between two hosts where information such as source and destination IP, source and destination port, bytes transmitted, protocols, etc. are collected and transmitted to QRadar by network devices. The QFlow collector reads packets from the wire or receives flows from other devices. QFlow collectors convert all gathered network data to flow record similar normalized events. They include such details as when, who, how, much, protocols, and options. QRadar flow collector component is present in flow processors, all-in-one appliances, and QFlow collector appliances. QFlow collector appliances are capable of collecting layer 7 flows, whereas flow processors and all-in-one appliances can only collect layer 3 flows. All data collected by QRadar, regardless whether it's flows, events, or even vulnerabilities, can then be reported over time. QRadar has over 1,000 of report templates available, and you can create also new templates or change the existing ones. Assets and asset profiles created for servers and hosts in your network provide important information to assist you when resolving security issues. Using the asset data, you can connect offenses triggered in your system to physical or virtual assets to provide a starting point in a security investigation. QRadar provides a unified view of the known information about the assets in your network, such as IP addresses, services listening on open ports, and or vulnerabilities. As QRadar discovers more information, the system updates the asset profile and incrementally builds a complete picture about the asset. Asset profiles are built dynamically from identity information that is passively absorbed from event or flow data, or from data that QRadar actively looks for during a vulnerability scan. You can also import asset data or edit the asset profile manually. As more information is provided to the system through vulnerability assessment, the system updates the asset profile. Vulnerability assessment profiles use the correlated event data, network activity, and behavioral changes to determine the threat level and vulnerabilities present on a critical business asset or assets in your network. You can schedule scans and also import scan results from third-party scanners and ensure that vulnerability information is relevant for assets in the network. For example, you can schedule NASA's, Nmap, an IBM Security QRadar Vulnerability Manager scanner directly in QRadar SIEM. For other scanners, you schedule only the collection of scan results in QRadar SIEM, but not the scan itself. You can add the separate product IBM Security QRadar Vulnerability Manager with the QRadar SIEM. This product requires a license to run on the SIEM. It contains an active scanner present on all QRadar event and flow collectors as well as processors. It can detect over 70,000 vulnerabilities. It processes results from IBM hosted scanner to see a view from outside your firewall. It tracks common vulnerabilities and exposures, and it also has the ability to process third-party vulnerability data feeds. The two most common methods used by QRadar to gather asset information are active scanning and passive detection. QRadar uses scanners such as the QRadar Vulnerability Manager scanner, Nessus, Nmap, Qualys, and others that provide a list of hosts with risks and potential vulnerabilities. They also provide IP and MAC addresses as well as open ports, services, and versions. It also lists the operating system of the systems. It provides a very detailed host information as well as policy and compliance information. It gets out of date quickly because full network scans can take weeks if not longer to complete. Active scanners may not scan past firewalls. And also, users can hide from active scans by shutting down their systems during the regular scans. Passive detection uses flows from Qflow or other flow sources in accounting technologies such as IPFix, NetFlow, SFlow, and others. They provide IP addresses in use, open ports in use. It provides real-time asset profile updates. Firewalls have no impact here, and the end users cannot hide. It also provides policy and compliance information. It's not as detailed as active scans. It does not detect installed but unused services or ports. QRadar product portfolio ranges from areas such as log management, SIEM, network application visibility, risk and vulnerability management, all the way to network forensics. The Log Manager is an appliance capable of collecting and processing events. It contains a correlation engine and can be upgraded to SIEM. The QRadar SIEM or SIEM has the ability to process events, network, and queue flows. It also processes and integrates vulnerability data. It can perform log management. It can also correlate events and create offenses. It can integrate with other products such as Risk Manager, Vulnerability Manager, and Forensics. It can be used in an all-in-one or distributed environment. The QRadar Qflow appliances are capable of collecting Layer 7 or application flows. This allows for application monitoring. The QRadar risk and vulnerability systems allow for network security configuration monitoring. The vulnerability scanner permits visualization of vulnerabilities of systems. Together, they can be used to predict threats via simulations. QRadar is a scalable product. It can be first deployed as a single appliance or all-in-one and then add systems such as collectors, processors, risk manager, data nodes to increase storage capacity, and others. It can also be deployed in remote sites. It can be deployed in high availability and used in disaster recovery environments. Network forensics can be integrated with SIEM or operate as a standalone. It permits rebuilding network sessions from PCAP and as a result provide additional clarity around who, what, and when. QRadar can be deployed in an all-in-one or in a distributed environment. In an all-in-one environment, a single appliance is dedicated to collecting, processing, and handling all event, flow, and vulnerability data. All data will be stored locally by default. In a distributed environment, QRadar will have different appliances doing different things. For example, it will have a console that handles all offenses, reports, configuration, etc. It can have flow and or event collectors and also event or flow processors in the environment. Each appliance will have a separate role in the environment. In the distributed deployment, systems can be deployed in the same data center or remote sites. This slide depicts a distributed deployment with different appliance types. In all deployments, there can only be one console. The console may have several managed hosts. Managed hosts are appliances that collect and or process event data and send the metadata to the console. In this case, we have a console located in the center of the slide, showing as a 31XX console. To the right, there is an incident forensics appliance and two packet capture appliances. To the left of the console, we see several event processors and collectors. Collectors, regardless of type, need to be associated with the processor since they only normalize data. They do not test or store the data. To the bottom of the screen, there are several flow processors and flow collectors. If you notice, the flow collectors are associated only with the flow processors. Data nodes are appliances used to add storage capacity to a deployment. They must be associated with a processor or a processor-like appliance. All these systems, with the exception of the console, are considered managed hosts, since they are managed and controlled by the console. There are three different types of console appliances. The 2100 series can only be deployed in an all-in-one environment. This appliance is designed for smaller environments. The appliance has a 2.6 GHz 6-core processor and comes with 32 gigs of RAM and a total of 1.5 terabyte storage capacity. It has a one management interface and three network interfaces, as well as an IMM interface for remote management. It can handle QFlow traffic up to 250 megabits per second, a maximum of 1000 EPS or events per second, and up to 50,000 flows per minute. The next type of appliances is the 3105 series. They can either be deployed in an all-in-one environment or in a distributed environment. This type of appliance is designed for medium environments. The appliance has two 2.6 GHz 6-core processor and comes with 64 gigs of RAM and a total of 6.2 terabyte storage capacity. It has a one management interface and two network interfaces, as well as a IMM interface for remote management. It can handle up to 5000 EPS per second and 200,000 flows per minute. The last console type is the 3128 appliance series. It can also be deployed in an all-in-one environment or in a distributed environment. This type of appliance is designed for larger environments. The appliance has a 2.8 GHz 10-core processors and comes with 128 gigs of RAM and a total of 40 terabytes storage capacity. It has a one management interface and two network interfaces, as well as an IMM interface for remote management. It also supports fiber channels. It can handle up to 50,000 EPSs and 300,000 flows per minute. Processor appliances are divided in two types, the XX05 and the XX28 series. XX05 and XX28 define the hardware configuration. XX05 series have two 2.6 GHz 6-core processors and comes with 64 gigs of RAM and a total of 6.2 terabyte storage capacity. It has a one management interface and two network interfaces, as well as a one IMM interface for remote management. The XX28 series have two 2.8 GHz 10-core processor and come with a 128 gigs of RAM and a total of 40 terabyte storage capacity. It has one management interface and two network interfaces, as well as an IMM interface for remote management. It supports fiber channels. The first two numbers of the appliances define the purpose of the appliance. 16XX indicates that the appliance is an event processor. 1605 appliances can handle up to 20,000 events per second, and 1628 appliances can handle up to 40,000 events per second. 17XX appliances indicate that they are flow processors. 1705 appliances can handle up to 600,000 flows per minute, and 1728 up to 1.2 million flows per minute. 18XX appliances are combo appliances because they can handle and collect and process both events and flows. 1805 can handle up to 5,000 events per second and 200,000 flows per minute, and 1828 can handle up to 15,000 EPS and 300,000 flows per minute. Data nodes such as 1405 use the XX05 hardware, and 1428 data nodes use the XX28 hardware configuration. Data nodes do not require EPS or flow licenses. Packet capture and incident forensics appliances use the same XX28 hardware. Flow collectors are similar in many aspects of their hardware configuration. Flow collectors differ mainly in what type of network interfaces they have, such as NAP attack, and the traffic rate they can handle. For example, the lower-end 1201 appliances can handle traffic rate up to 1 gigabit per second. The higher-end appliances, the 1310, can handle traffic rates of up to 10 gigabits per second. The Event Collector 1501 appliance is a dedicated event collector. It has a one 2.6 GHz 6-core processor and 16 gigs of RAM. It has only 600 gigabytes of storage capacity for temporary data storage. Dell console and processor appliances are very similar to the ones described in the previous slides. Dell appliances are currently offered only to customers who cannot purchase Lenovo systems, such as US federal government. Dell flow collectors are also very similar to Lenovo flow collectors in terms of hardware. There are three appliance types currently offered, the 1202, 1301, and the higher-end 1310 that can handle up to 10 gigabits per second. By default, a dedicated event collector collects and parses events from various log sources and continuously forwards these events to an event processor. You can configure the QRadar Event Collector 1501 appliance to temporarily store events and only forward the stored events on a schedule. A dedicated event collector does not process events, and it does not include an onboard event processor. QRadar appliances can be offered both in hardware and virtual appliances. The hardware appliances are offered as all-in-one appliances, console, event processors, flow processors, event and flow processors, or also known as combo processors, queue flow collectors, and risk manager. It can also be offered as forensics and packet capture appliances. The virtual appliances are just QRadar appliances running on virtual hardware. It is a pre-configured ISO of QRadar and operating system configured to deploy and run on a VMware infrastructure. These are usually installed by the customers themselves. Any VMware infrastructure, whether it's simple virtual machine, private cloud, or public cloud, with the appropriate hypervisor version is supported. Both virtual and hardware appliances are both delivered as an ISO. They are Linux-based and no operating system administration is required. Deployments can contain both virtual and physical appliances in any combination. The activation code will identify the type of system at install time. There are several storage options that should be considered when deploying virtual or physical appliances. For virtual appliances, you should consider using local VM storage. It's easier to manage, but the performance is lower. Or you can also use remote mounted SAN NAS storage, which will be faster. There are two options for QRadar appliances. You can use the onboard disks for storage or use a SAN, which will require a fiber channel card to be installed on the appliance. This concludes the first part of IBM Security QRadar SIEM Foundations course.